Next we turn to reorder point when demand and lead time are variable, okay, or they are not constants, in other words. So if the demand and the lead time were constant, then we already saw the reorder point can simply be calculated as D times L, with D being the demand per period and L being lead time in the same periods as D is expressed. So demand per day, that means you have to express L in days, and you multiply D and L, and that's your reorder point. And this is the graph that we saw, where with constant lead time and constant demand, D times L is the ROP, and when you reach that point, you know exactly how much you need to have in stock, so you place an order, and that level of stock is sufficient to satisfy the demand during lead time. And when you run out of stock, your lead time will be over and the new order comes in and everything is all right. But what if the demand is not constant, or the lead time is not constant, or both are not constants? Then your demand rate is not going to be exactly the same every period. It could be a little steeper or a little flatter, right? So to avoid that situation, what we will do is, instead of just using D times L as our ROP, we add what is called a safety stock to it. So your average demand during lead time plus a safety stock. Okay, you may not need the safety stock all the time, but when the demand is more, because of the variability in demand, if it's more than, if the demand curve is steeper than normal, then you will have some cushion. So it will be something like this. So if it is a little steeper, then you're running out of stock before the new order comes in and you end up with a stock out. But if you have a safety stock, so instead of 0 units, you have safety stock, then, okay, so that part will occur here, and you still have the safety stock on hand, which will come in handy, and stock out is avoided. Okay, so the question is, how much safety stock should you add? Now that depends upon two factors. Okay, one is the variability in demand during lead time, how variable it is. Okay, if the variability is very small, then small amount of safety stock is sufficient. Okay, for example, if there is no variability at all, then you need 0 safety stock. So if the variability increases, then you'll need more safety stock to protect against stock out. So that's one thing. And the second thing is, whatever the variability may be, okay, there is always going to be a probability of stock out. So for example, here, if the safety stock is smaller, okay, like over here, then you would have run out of stock. If the safety stock is over here, then you wouldn't run out of stock even if the demand is really steep going this way. Okay. So the question then is, what is the probability of stock out that you're willing to accept? Okay. And that is usually expressed as a service level, that is 1 minus probability of stock. What is the probability of not running out of stock? Okay. If you want that probability to be high, then you need to have a lot of safety stock. Okay, like if you want 90% probability of not running out, or 95% probability of not running out. So between 90% and 95%, for 95% you must have larger safety stock. If you want 99% service level, with just 1% probability of stock out, then you need even higher level of safety stock. So two things determine the level of safety stock: how much variability there is, and what is the service level that you desire. Okay, so you have to specify the service level, which is 1 minus probability of stock out. Okay. Then ROP is now average demand during lead time. Okay, and then you add a safety stock and you get Z from the service level that you desire. Okay, from the normal probability distribution that now we are going to assume that demand during lead time is going to be normal. Okay, then that will be a cumulative probability. Service level will be cumulative probability, and you look up the z value, and then you need to have the standard deviation of demand during lead time. So that subscript DLT stands for demand during lead time. So you have to know this. You need to know that. So that the larger the standard deviation, more variability there is. Smaller the standard deviation, less variability. And again, larger the service level you need, larger will be the value of z. And smaller service level, smaller will be the z. So z times standard deviation gives you the safety stock. You add it to ROP. Okay. So here is an example. Or in a company, item A 338 is normally distributed demand. The mean is 350, standard deviation is 10, and you want 95% service level. So stock out should occur only 5% of the time. So let's head on over to Excel. So the mean is 350. So here we are not using D times L because D times L is given. If D is given separately and L is given separately, then we can multiply the two together. But here mu is given, the lead time for the demand during lead time is given. Okay? So 350 standard deviation is 10, service level is 95%. So remember, service level is a cumulative probability. So it's that the service level is that 5% is the probability of stock out. So z value then is, okay, from our probability chapter, we know that the z value is norm dot s dot inv. Okay, so for that probability. Okay. Then z times standard deviation of demand during lead time. That's our safety stock, and then our ROP will be demand during lead time, the mean demand during lead time plus safety stock. So that will be our reorder point.